Okay, the product rule of roots. Roots are the like the square root, cube root, fourth root. Okay, this symbol, right here is called the radical. None of this stuff is super important, but you are going to see these terms, these vocabulary from time to time. This is called the radical. The 2 is the index. And the 3 is the radicand. And again, the radical is kind of important. The index we'll use from time to time, but that's what all that misery is. Now the product rule of roots is real simple. It's just like, or it's very similar to uh, the rules for exponents. If we have the square root of 4 times the square root of 5, this is the square root of 20, right? 4 times 5. I think this word is actually indices, is the plural of index, but we'll say indexes. The indexes must be the same. So if we had the square root of 3 times the square root of 6, I'm sorry. Well, let me go ahead and do that. That's the square root of 3 times 6, which is the square root of 18. Now, if we have the cube root of 5 times the square root of 3, there's nothing we can do here, because remember the indices, if there's not one in there, it's assumed to be a 2 square root. This is called the cube root. And if there was a 4 for the index, it's the fourth root. So there's nothing you can do here. This is just the cube root of 5 times the square root of 3. There's nothing you can do. Now if we have this, if we have the square root of 7a.
So we don't do nothing with the 2?
You talking about the index?
Yes.
No, don't have to. You can put it in there if you want, but remember, if it's not shown, if it doesn't show there, it's assumed to be a 2. Everybody got that? Okay, so if we have the square root of 7a times the square root of 10b, this equals the square root of, now the indices are the same, so we can multiply what we can multiply. 7 times 10 is 70 AB. Right? Now the quotient rule, the quotient is the answer when you divide. The quotient rule is just like this, except for division.
What you drinking?
It's Thursday.
I know it.
It's tequila. Oh, it's Thursday. Oh, date night. And she's good looking too. Okay, so if we have the square root of A divided by the square root of B, again, we have the same indices. You can put it under the same radical, square root of A over B. Same thing. Therefore, if we have the square root of 9 over 4, that equals the square root of 9 over the square root of 4. Or you can do it like this. And what's the square root of 9? Plus or minus 3. Square root of 4 is 2. Plus or minus 2. Okay, or you can just do it from here if you want. That's okay. All right.
So we don't put a radical on top of that?
On top of this?
Yes.
No. Yeah, thank you for asking that. Because when we take the square root of 9, what is the square root of 9? 3. It's not the square root of 3, it's 3. Everybody got that?
Okay.
Okay, yeah, thank you for asking. That's one that seems to get everybody. Okay. Now, simplifying roots. If we have the square root of 8, now what we want to do here is we want to factor the 8 where one of the terms, one of the factors, is a perfect square. This equals the square root of 4 times the square root of 2. Square root of 4 times the square root of 2 is the square root of 8. Now the square root of 4 is 2. And the square root of 2, we don't know and we don't care. Leave it under the radical. Just like that. And the square root of 32. What are the factors of 32 where one of them is a perfect square?
84.
16 times the square root of 2. Square root of 16 is plus or minus 4. Square root 2. And the square root of 75. Now what will go into 75 where one of the factors is a perfect square? A lot of times if you think about money, it helps.
25 times 3.
Good. Square root of 25 times the square root of 3. 25 times 3 is 75. Square root of 25 is 5. Square root 3. We don't know what the square root of 3 is and we don't care. Okay, now remember, excuse me, remember, what does the square root symbol mean, or the radical, what does it mean? It means what number times itself. What number times itself is a squared?
1, A.
Just a, right? A times a is a squared. What we're doing is, excuse me, remember the index is 2. So what we're doing is we're dividing this 2 by that 2. That's a to the first. Or if we have the square root of b to the fourth power, what number times itself? What number times itself is b to the fourth? B squared. B squared times b squared is b to the fourth. Again, what we're doing is the index there's 2. 4 divided by 2 is 2. Now get this if you're so smart. The square root of c to the 5th power. Now what can we do to this? How can we factor the c to the 5th? Because we've got to have this has to be an even number if our index is 2. So it's going to be the square root of c times the square root of c to the 4th. Square root of c times the square root of c to the 4th is the square root of the 5th. What's the square root of c? We don't know, we don't care. Square root of c to the 4th. Now once you take the square root of it, it comes out of the radical. Radical goes away. And what if we have the square root of d to the 7th? Again, we want an even number here because we want to divide the 7 by this 2. So we're going to have the square root of d to the 6th times the square root of d. Right? Square root of d to the 6th times the square root of d is d to the 7th. So we're right. Now what's the square root of d to the... This is fun stuff here, huh? Yeah, this is good stuff. Square root of d to the 6th. Remember, we're going to divide this by 2, by the index. So it's going to be d cubed. Now again, once we take the square root of it, it comes out of the radical. And the square root of d is, we don't know, we don't care. This is fun stuff. This stuff had put amphetamine freaks to sleep. Okay, what else do we have here? Is everybody okay with this? It's really very simple. It's just really different than some of the stuff we've had. Okay. Now the Pythagorean theorem, hopefully you've seen before. Now this only works with right triangles. Pythagorean theorem. Now this guy lived about somewhere 300 to 400 BC. Long time ago. No calculators, no cell phones, no computers. They didn't even have a decent numbering system. Now how this guy ever came up with this idea, boy, he's a better man than I, Gunga Din. Okay, remember, only right triangles. GHT. This is something you might actually use in real life. Probably not, but could be. For instance, if you're setting up a baseball field, how in the world are you going to find where second base goes? You have to use the Pythagorean theorem. if you want to get it in the right place. Okay, this is, oh, before I forget, if the problem states a lowercase letter, use a lowercase letter. Do not change it, because you'll see here in geometry, sides are lowercase letters. Angles, this would be capital A. Capital B, the angles are capital letters. The sides are lowercase letters. But Pythagorean theorem states this: a squared plus b squared equals c squared. Now this guy Pythagoras, we have pictures of him that we think is him. And man, this guy is triple ugly. So no cell phone, no computer, no interweb, nothing fun. So, and he was triple ugly, so he couldn't get a date. So what else did he have to do other than this? So if A is 3 feet, B is 4 feet, and we want to know what is C. Okay, A, B, and C. Now, A and B are interchangeable. They can be either one. It doesn't make any difference. But the hypotenuse, this is called the hypotenuse. Not very important, but the longest side, always, I know always is a long time, but it's always the longest side. If it's not, it's undefined. So what is the value of A? 3 squared, plus B is 4 squared, and C, we don't know. Now this is order of operation. Hey, y'all realize we're 20% finished with the semester. I hate to tell you, I told you so, but I told you so. It's going to go real fast. Now we just do order of operation here. 3 squared plus 4 squared, 3 squared. We don't have any parentheses, but we do have exponents. It says 9 plus 16 equals x squared. 9 plus 16 is 25 equals x squared. And we don't want to know what we don't want to know what x squared is. We want to know what x is. So how do we find out what x is? Square root. Whatever you do to one side, you have to do the other. So x is it plus or minus 5? No, because this is distance, and distance is always positive, except maybe in Bizarro World or something. Okay, Pythagorean theorem. I have a picture of what we think he looks like. Nobody really knows for sure, but because they didn't have any cell phones back then, so there wasn't any way to take a picture. So what if we have this? Please think. Six feet. We don't know how many feet. And 10 feet. And again, Pythagorean theorem is a squared plus b squared equals c squared. What's our a? These are called legs. The two legs are called legs. The two legs are these. And this is actually a leg too, but it's called the hypotenuse. Excuse me. A and B. And remember, they can be either one. This can be B and this can be A. It doesn't make any difference. But this one, the hypotenuse, the longest side, must be C. So what is our A? 6 squared plus, what's our B? We don't know. Equals 10 squared. Six squared is 36. This is about as difficult as these problems get, and it's really not all that hard. Very simple algebra problem. Subtract 36 from each side. And we take the square root, so x is 8. Now, when you're doing this, feet, especially if you're using a calculator, you have to ask yourself, is it reasonable? Does it make sense? If you don't ask yourself anything else, ask yourself, self, is the hypotenuse the longest side? If you don't ask yourself anything else, ask yourself that. Is the hypotenuse the longest side? Yes. So we're probably correct. Mm-hmm. Mm-hmm. Okay. This is not important, but the little box here means that this is 90 degrees and that it's a right triangle. You cannot assume. Assumption is the mother of all mistakes. So you have to make certain. I don't think you're going to get anybody that's going to try to fool you with that little box not being there. And sometimes I forget to put it in there. Or sometimes you'll see a triangle and they'll in the instructions they'll say a right triangle. So if we have come on, boy, think. 8 feet, 4 feet, and x feet. A squared plus b squared equals c squared. Now again, the two legs, the one on the two sides that are on either side of the right angle. Now again, remember, this only works with right triangles. This one's A, this one's B, this one's C. These two are interchangeable. It doesn't make any difference which one's which. But this one, the hypotenuse, the longest side, must be C. So A squared is 4 squared plus 8 squared equals x squared. 16 plus 64 equals x squared. What is that, 80? Square root. So x equals the square root of 80. As far as I'm concerned, you can leave it like this. Unless I say lowest terms. And then we'd have to take 4, no, 4 is 20, 16. I don't know. They're factors of 80 where 2 of them are perfect squares. Everybody okay with this? Anybody want another one? Come on, Luna. I know you want another one. Say it.
I'm ready to move on to the next one.
Okay. This fun stuff, huh? Okay. Pythagorean theorem. Okay. This is the last bit, and it's really, I just want to show you. Oh, does anybody want to do the sum or difference of cubes? Is everybody okay with it? Y'all did real well with those. Everybody okay with them? Okay. Complex numbers. I'm just going to show you this. I'm not going to irritate you with it on the test, I don't think. Oh, before I forget, Tuesday we shall review for the test. The test will be Thursday. You do not have to come to class Thursday, just do the test. Okay? Unless you want to.
Wait, can you repeat that one more time, please?
Yeah, we're going to review for the test on Tuesday. I'm going to go over every problem for problem. All I'm going to do is change the values. I'm going to change the numbers. And the test will be, I'm going to open the test on probably on Tuesday if I can remember. And don't come to class on Thursday. Do the test during that time. That makes sense?
Yeah.
No
Thank
class. No class Thursday. I'm sorry, Mr. Garcia, what?
you. Oh, I said thank you.
Okay. No charge. Okay, these are called complex numbers. I don't think, but to tell you the truth, tell you what, y'all hang on just a second. I've got the test made. Okay.
Negative 25.
Up until now, there wasn't anything times itself going to equal negative 25. Now this up until now was undefined. But now we have to have a way of dealing with this. So we use what are called imaginary numbers. And the square root of -1 is I, lowercase italicized I. Therefore, I squared is -1. Square this side, square this side. Now this is semi-important here. So what can we factor this into where we can get rid of this negative?
Make it into I.
Exactly, good. So this is the square root of -1. Now I'm going to go the long way around doing this. And the square root of -1 is I. The square root of 25 is 5. The 5 goes in front of, this is not a variable, but it kind of acts like it. Okay, whenever there's a negative number here, just bring out an I. So if we had the square root of -16, the negative turns into an I outside of the radical. That's the square root of 16. Then the negative goes away. So this is 4I. Okay, you can do it like this if you want. Put the -1 in there. And again, the square root of -1 is I. And the square root of 25 is 5. Okay, if you have this, if we have the square root of -36. Get rid of the negative, bring out an I. Everybody with me here? Okay, equals, and the square root of 36 is 6. I. Let's see. Okay, now the I is you can think of the I as a number. So if we have I divided by I is 1. Okay, so if we have this, the square root of -48 divided by the square root of -3. Now we can factor this into something that we can deal with, but let's just leave it like this for right now. We're going to bring the I out. Right? Now the i's cancel each other out. So we have the square root of 48 over the square root of 3. 16. And we could actually do the square root of 16 times 3 over the square root of 3. Square root of 16 is 4 times the square root of 3 over square root of 3. Square root of 3 divided by the square root of 3 is 0, so our answer there is 4. Right? Right. Let's see. Now, one other thing, if we have I times I times I is I squared, and the value of I squared we know, I squared is -1. We're going to use this a little bit. Excuse me. I'm going to irritate you with this problem from time to time. 2a plus I times 3a plus I. Distributive property. 2a times 3a is 6a squared. 2a times I is 2ai. Now we do the same thing with the I. I times 3i is 3ai. What am I doing here? Stupid boy. Plus I squared. Now remember, I squared is -1. So we're going to combine like terms. 6a squared. 2ai and 3ai is 5ai. Artificial intelligence. Plus 1. Remember, I squared is... Oh, no, not plus 1. Stupid boy. -1. I squared is -1. So let me rewrite this. 6a squared plus 5ai minus 1. Okay. 4 plus 7i times 4 minus 7i. Anybody tell me what this is? Anybody remember? This is a conjugate. Remember, these numbers are the same. The only difference is one's plus and one's minus. This is important. Okay, so we do 4 times 4 is 16. 4 times -7i is a -28i. Now we do the same thing with the 7i. 7i times 4 is positive 28i. And 7i times 7i, or times -7i, is a -49i squared. I times I squared. Middle two terms are opposites. And they cancel each other out. 28i minus 28i is 0. So we have 16 minus 49. Now I squared again is negative 1. So this is going to equal 16 plus negative times a negative is a positive. So this is going to equal, what is it, 65? I think. Oh, I got it. Now you got to admit, this is good stuff here. Let's drink. Oh, that's good. I know these kind of tend to get away from us from time to time. Let me do this. 10 plus 6i times 10 minus 6i. Okay, you need to look at these things and snap to the fact that they're conjugates. Because what will happen is you really don't have to do distributive property here. You just do the first numbers and the second numbers, because the middle two numbers, the linear terms, will cancel. So 10 times 10 is 100, as we say in North Katy. And 10 times negative 6i is negative 60i. 6i times 10 is a positive 60i. And 6i times negative 6i is a negative 36i squared. I times I squared. Middle two terms are common. They cancel each other out. They're opposites each other. So this equals 100 minus 36. And remember, I squared is negative 1. So this is going to equal 100 plus 36. Negative times a negative is a positive. So our answer here is 136. Right? Right. Okay. One more thing. It's a real simple. Oh no, two more things. You know what? I think I'll cross that one out too. Solve the quadratic equations. This is super simple. Let me see if I can find one real quick. No, you don't want to do that one. Don't want to do that one. Let's do this one. Let's see if there's an easier one. Okay. 2x squared plus 7x plus 6 equals 0. Now we want to factor this. Now remember, when the leading coefficient here, when the leading number here in front of the x squared is not 1, excuse me, we have to multiply a times c. This is a, that's b, and that's c. So we do 2 times 6, excuse me, is 12. Now what are the factors of 12 that add up to 7? Now everything in here is plus, so it's going to be x plus something and x plus something. 2 times 6, 3 times 4, right? Now which one do we want to put next to the 2? we want, again, what we're going to do is we're going to split this 7x into 4x and 3x. So we have 2x squared. Okay, now we do groupage. Now what can we factor out of this one? 2x. 2x times x, 2x squared. 2x times 2, 4x. Okay, we're right. Plus, and what can we factor out of this? 3. Now remember, these two factors must be the same. If they're not, something's wrong. So we have 2x plus 3 and x plus 2, all equal 0. Now to solve these quadratic equations, this is very, very simple. All we do is we take each one of these and set them equal to 0. So we have 2x plus 3 equals 0, and we have x plus 2 equals 0. Here, and now we have two simple algebra problems. Subtract 3 from each side. 2x equals negative 3. Divide by 2. X equals negative 3 over 2. And here we have subtract 2 from each side. X equals negative 2. Now if you plug these back into the original equation, it'll equal 0. I hope. Okay. Okay. Oh, I tell you a way to
The
cheat.
answer was 0 for both of them?
Say that again?
So the answer was 0 for both of them?
No. No, you set them equal to 0 and then you solve it. See, because our original thing is 2x squared plus 7x plus 6 equals 0. And once we, excuse me, once we factor this thing, then we set each one of the factors equal to 0. 2x plus 3 equals 0, and x plus 2 equals 0. And then you solve these equations.
Okay.
Okay? I'll show you a way of cheating here. If you've got your handy dandy graphing calculator, first thing is you turn it on. Go to y equals, clear it out. Now, if you put this quadratic equation in, 2x squared plus 7x plus 6, okay? Now, negative 2/3 is going to be at 3 halves, it's 1.5, which is about there. And negative 2 is about there. So it's going to make a parabola opening upward. Now, wherever the parabola crosses the x-axis, those are the answers. And we've got that in there. Can y'all see that? And then you hit graph. Graph is right over here. And if you look, see where the parabola crosses the x-axis, those are the answers. You can kind of double check yourself. With this calculator. Okay. Let me do another one. X squared minus 9. They look familiar? This is a conjugate. It's going to be x plus 3 and x minus 3 equals 0. Now we set each one of these equal to 0. X plus 3 equals 0 and x minus 3 equals 0. subtract 3. We get x equals -3. And here we're going to add 3 to each side. X equals +3. And again, if you're not sure, you want to double check yourself, turn on your handy dandy graphing calculator and you put in the original equation, x squared minus 9, x squared minus 9. And before you leave the screen, double check, graph it, -3, positive. See where the parabola crosses the x-axis? Okay. Let me see. What else? Okay. Let me do one more of these stupid things. -3 minus 2i. Let me just do this one and then I'll let you go. Times -3 plus 2i. What is this?
A conjugate.
Excellent. It's a conjugate. Same numbers. The only difference is this one's negative and this one's positive. Okay, so we have, now I'm going to go ahead and do the distributive property here. But you really don't need to. Once you've identified this as a conjugate, all you really need to do is multiply this times this and that times that, because all the linear terms are going to be eliminated. But I'm going to do it anyway. -3 times -3, excuse me, is a +9. -3 times a +2i. Am I going too fast? Please tell me if I'm going too fast. A -3 times 2i is a negative. Is that right? My brain just went numb. I think that's right. Now we have -2i times -3. Negative times a negative is a positive. Come on, stupid. 6i. -2i times a +2i. Negative times a positive is a -4i squared equals 0. And remember, we know the value of I squared. It's -1. Now we have like terms here and here. 6i minus 6i is 0, gone, eliminated. So we have 9 minus 4 times, and again, I squared is -1 equals 0. So now we have 9. -4 times -1 is +4, not equals 0, stupid boy. 9 plus 4, -4 times -1 is +4. So our answer here is 13. Everybody okay with this? The only real kind of fly in the ointment here is, what is the value of I squared? -1. Everybody got it? Anybody want me to do anything else? Go back over anything? I'll send you a copy of this on the YouTube video. It takes it a while to process, so I'm not going to be able to get it tonight, but I will get it to you if I'm not too hungover. I'll get it to you in the morning. Any questions? Okay.